Hi there. My name is Jenny Kim Nguyen, and for this study, I want to present to you microplastics in water and air in the urban environment using visual identification and pyrolysis gas chromatography mass spectrometry. So microplastics are really tiny, about less than 5 millimeters, plastic particles that are derived from plastic breakdown and byproducts. This forms various shapes, colors, and sizes with different polymer mixtures. Due to their durability and size, they are very difficult to remove from the environment, especially in air and water systems. So why is that important to us? It's an emerging hazard in terms of environmental and human health, and its persistence continues to raise concerns. So for the sample location, three factors were tested for air samples. So it was indoor and outdoor and roadside. Indoor and outdoor air was collected in Arlington, Texas, and roadside air was a collaboration with Texas A&M. And they had a mobile moving car with a filter attached to their car to collect this roadside air. And then for water, it was collected around Tarrant County, and we collected wet and dry samples. So after collecting the samples, the water was really suspended and dirty. So we had to do microfiltration followed by biological digestion to reduce this noise and this signal to noise ratio discrepancies. So after doing sample prep, I visually identified it and analyzed them using a binocular microscope at 4 times magnitude. I found that both air and water samples contain microbeads, micropellets, and microfibers. Um, the sizes and shapes had no correlation with each other in terms of air and water samples, but I did find that water samples experienced more color plastics compared to air. And after visually identifying them, I chemically analyzed them using a pyrolysis gas chromatography mass spectrometry. And here are the target polymers and oligomers for each plastic polymer, and then the instrumental conditions, as well as the LOQ and LOQ water and LOQ air. And for our results, um, I compared air and water, and I found that water experienced about 3 times more microplastic concentrations in micrograms per grams than air samples. But air samples did experience more diverse compositional profiles compared to water. And then I also compared the air and water concentrations to their daily average temperature collected at that time and date. And I found that microplastic concentrations in air were more influenced than water. You can see this with the R-squared value of 0.5 compared to 0.1. This means that other meteorological and social economic factors are contributing to this microplastic concentration rather than just temperature alone. I also compared air concentrations with each other, not just to air and water. And I found that roadside was significantly less than indoor and outdoor, but roadside had a more diverse microplastic profile compared to indoor and outdoor. This variation could be due to human industrial and traffic activity that causes a lot of erosion and atmospheric deposition to contribute to this variation. And also comparing the water samples to themselves. So I had a baseline and an episodic. So baseline was the dry season and episodic was the wet season. So looking at this, episodic water samples were about 1.5 times higher in microplastic concentrations of micrograms per grams compared to dry. These results actually aligned with Van et al., where theirs was about 1 to 2 magnitude difference. This could be due to increased hysteresis effects and surface runoff to contribute to this big episodic concentration. And to wrap things up for future plans, we're hoping to get more technical improvements in samples to find better correlation relationships. And we want to do more advanced visual identification rather than just microscopy, such as laser identification and particle size distributors to better understand how this morphology will affect different matrices. And just overall, we acknowledge that the fate and transport of microplastics are still a complex research, and we definitely need to have more research and definitive conclusions reached, considering the fact that it is a very harmful pollutant. And that concludes my presentation. I want to thank the Earth Environmental Sciences Department and collaborators for providing me this opportunity to carry out this study. Feel free to reach out to me for any inquiries that you may have, and thank you for your time.